Hey guys, we have one more learning goal. It states, determine the mean and the median in the interquartile range to create a set of data. Okay, so let's take a look at a couple questions we can do on this page that we can pick that we can try to get right, okay? So maybe we'll pick this one. In a normal distribution with the mean of 64 and a standard deviation of 4. So what does that mean? All right, so if you have a normal distribution and the mean is 64 and the standard deviation is 4, what that means is that there's 3 standard deviations above and 3 standard deviations below. Okay, so what would that look like? So each standard deviation is 4, so this would be 68, 69, 70, 71, 72, 73, 74, 75, 76. All right, then working backwards, this would be 60, then 56, then 52, okay? So what did I do there? I took the mean, 64, and I added 4, and then I added 4 again, and then I added 4 again, and then working backwards, I took 64 and I subtracted 4 and subtracted 4 and subtracted 4. Okay, so what does this mean? Well, we have a formula that says that if the data is normal, 68% of the data is within 1 standard deviation, plus or minus. 68, 95% of the data is within 2 standard deviations, and 99.7% of the data is within 3 standard deviations. So by the time we get 3 standard deviations away, almost all the data is included. That's what standard deviation means. So what percent of our data is within 52 and 68? All right, let's piece this out. So this is 68% is within 1 standard deviation. And then we know this direction. So we have to figure out what's in this tail here. In between here, or this whole tail, is half of 97. So 99.7 divided by 2. What would be this whole piece? Would be half of 99.7. So let's get our calculator out. 99.7 divided by 2. Let me do that again. 99.7 divided by 2. $49.85. Okay, so $49.85 is this whole thing. And then I still need to add in the other half of the 68%. So half of 68 is 34. So I need to add 49 and 34. So let's add 39 to that, plus 39 to that. Wait, I wanted to add 34 to that. So I accidentally added 5 more. Sorry about that. Okay, so 83.85. Let's see here. 83.85. There's our answer. 83.85. Nice work. So what percent, this is our final 3 standard deviations through the mean. We know that that is between 52 and 76. How do I get these numbers? I took 64 plus 4 plus 4 plus 4, and I got 76. Then I took 64 minus 4 minus 4 minus 4, and we got 52. Well done, guys. All right, so we got to pick one more that we think we can answer under this learning goal. Let's take a look at number 5. All right, in a local park, Jeremy collected data on the heights of 2 types of trees. Okay, we did something similar to that. So this is the median, and this is the median. So type trees in A have a higher median, right? 18 is higher than 16. What else do I notice? Okay, well, I noticed the range, max minus min. Type A has a higher range. These range from 22 all the way down to 8. This one ranges from 21 down to 11. So there's much more spread outedness or range there. What do I notice that's similar? I notice that they have the same. Tree A and B have the same interquartile range. So what's the interquartile range? It's quarter 3 minus quarter 1. 20 minus 12 is 8. Here, 20 minus 12 is 8. Those are exactly the same number. Okay, so the inner 50% of the data is the same in the group, the same range. That's called the interquartile range. So now let's answer our question here. It says, compare the two centers, and we did. Tree A has a higher median. Then compare the spread outedness. We did. Tree A has a higher range. That's the spread outedness. So what else could be the spread? That's the interquartile range. So spread means range, means both. Interquartile range, so the spread of the middle half of the data and the spread of the entire data, okay? So when they ask for spread, they're talking about the interquartile range and the overall range. Nice work, guys. See you next time.